Here is a section of the table, and I try to provide a snapshot here. You can view the full table in the back of your book or provide it on your homework site. As you can see on the graph above the table, the area provided inside the table is the area to the left of any specific z-score, and the z-score are listed here in the outer columns and the above rows. If you want to find the area to the left of any z-score, that is the four uh, decimal digit number or the 5-digit number provided inside the table. If you want to find the area to the right of any z-score, you want to subtract it. Or if you want to find area between any two z-score, as I showed on the previous um, video, you can find the area to the left of the outer right z-score minus the area to the left of the lefter z-score. And we can go through some example to make sense of them. So let's look at some simple example. First example, how to find the area to the left of a specified z-score. So here, first of all, I will try to draw out a standard normal curve. I really encourage you in this section to also draw out a curve because visually it helps you look and see what area you're supposed to get and how to go to the table. Once you get used to it, this step can be omitted, but it's always really helpful. So here I want to find the shaded red area to the left of the value z equal to 1.38. So here, since I see that this z-score 1.38 is positive, I would go to the second page of the z-table where they list all the positive z-score. I would go down to the outer column to, to go to 1.3 as I can see right here, and then I will go to the right to match all the top value, the second decimal place of z to 0.08 because 1.3 plus 0.08 will make a 1.38, and I can see the area given is 0.9162. Thus, the area to the left of z equal to 1.38 is 0.9162, or the probability of the variable z having values less than 1.38 is 0.9162. So as you can see, if you want to find the area to the left of any specified z-score or the probability of a variable having a value less than z equal to 1.338 is fairly straightforward. You just have to go to the z-table and find the area listed there. Let's look at the second example. Let's find the area to the right of a specified z-score similarly to that. So here I have the standard normal curve and I have z equal to 1.58. The area in red is shaded to the right of z equal to 1.58. So I am interested in finding the area to the right of 1.58. Similar to the previous example, since my z-score is positive, I would go to the second page of the z-table again, and I would go down to see in the outer column to reach 1.5 right here, and I would go to the right to match the second decimal place of z, 0.03, because 1.5 plus 0.03 will make a 1.53. And I go down here, the intersection of them will make 0.9370. But hold on, this 0.9370 is the area to the left of 1.53, or the non-shaded red area. To find the shaded red area, you need to do one subtract what the table gives you to have 0.063, or the probability of a variable z having values greater than 1.53 is 0.063. So very similar to the last example we have, just one extra step. So to find the area to the right of any specified z-score, don't forget to subtract what area the table gives you from 1. Let's look at the third example, finding area between two specified z-scores. So again, I would have the standard normal curve here for easy illustration. I have the first z-value to be negative 0.25 and the second z-value to be 1.87, and I'm interested in finding the area enclosed in between them, or the shaded area here. Since I see that the left z-value negative 0.25 is negative, I will use the first half or the first page of the z-table. I would go down to negative 0.2 and I would try to go left to match it with 0.05. Here I don't show the full table here because limited space on the slide, but if you follow with your z-table at hand, it would be not very hard for you to look, and you can see 0.4013 right here. Okay, let me go back a little bit. Also, if I look at 1.87, I see that this z-score is positive, so I will use the second page of the Z table. I will go down to 0.18 right here and will go right in the table to match with 0.07. The intersection of them will give me the area to the left of 1.87. Or if you follow through with your table, you'll have the value 0.9693. If you remember the diagram I showed you in the previous video, to find the area in the middle of 2 z-score, I would use the area to the left of the rightmost z-score, in this case 1.87, subtract the area to the left of the leftmost z-score, in this case negative 0.25. So the area in between would just be the difference between these two numbers, and that would turn out to be 0.5680. So here, the probability of the variable z having values between negative 0.25 and 1.87 will just be the difference of those two values you just found, 0.5680. Not too bad, right? So if you have to find area for any specified z-score using this table, it will fall into one of the three categories we discussed before, either to the left of some z-score, to the right of some z-score, or sandwiched between any two z-scores. So you can refer back to these three examples and try to find all the areas that you're interested in. I recommend doing some homework problems or do some more example to get used to how to use a z-table, because as you know, finding the area is not just simply finding the area, it's also finding the percentage of all possible observation lies within any specified range. Also, that means finding the probability of any interested variable, just like how we discussed in the very first section of this chapter, the density curve. Okay, so let's move on to another very important concept, the z sub alpha notation. So here you see z and the Greek letter alpha. The Greek letter alpha is a little bit beneath z, so we usually call it z sub alpha. It is used to denote the z-score that has the area equal to alpha. Here, don't be scared, alpha. It is just a Greek letter, denotes some numerical values you will see in a little bit. Has the area of alpha to its right under the standard normal curve. So alpha again is any constant. So here I have some example so you can see how to find this. Just a word of caution, most students get confused this with the common z-score, since it usually refers to the area to the right, but not the area to the left, as the table give it to you. So make sure you understand this difference between them to avoid making a mistake. The z-score before the area given by the table refers to the area to the left of the z, but z sub alpha is a z-score that gives you alpha as the area to the right. Okay, so let's go into the first example on how to find z sub alpha. So in this problem, I'm interested in finding z sub 0.05. So here, my alpha is 0.05, or the shaded area to the right of z sub 0.05 is 0.05. That means the area to the left of z sub 0.05, or the non-shaded area, is 0.95. How do I get that? I just do 1 subtract the red area. That is how I get 0.95. Okay, so now 0.95 is the area which correspond to these values inside the table. So what I have is a problem that is opposite of what I had before. Now I have area, I need to find z-score. In contrast with before I had z-score, I try to find area. So if I go inside the table, I try to see where the table gives me the area closest to 0.95. With a little bit of searching, I can find right here. It is in between 0.9495 and 0.9505. Indeed, it is exactly in between right there. So if I match this out to the left, I can see it takes the value z1.6 and then match it up. It's between 0.04 and 0.05. Sometimes some book or this book take right in the middle 0.045. Plus, when you add these two values together, you get 0.645. So z sub 0.05 is 0.645. Sometimes you can go with 0.64 or 0.65. It doesn't really matter. Okay, so you can see that this value 1.645 will give you 0.95 as the area to the left of it and 0.05 as the area to the right of it. So as I said a minute ago, it is exactly the reverse process of what you did before. So it is important that you can go back and forth between finding the area when you have z-score and finding z-score when you have area, and try to know the distinction between the two. Okay, let's look at another example to find z sub alpha before you can go and do your own homework or your own example to get used to it. So find another z sub alpha. In this problem, I want to find z sub alpha in both of the tails. Okay, so I want to find z sub 0.025 and negative z sub 0.025. So one thing at a time. So last example, you saw that z sub 0.025 give you the area, the red area to the right to be equal to 0.025. As you remember, one of the property of the standard normal curve is symmetric. There are actually several ways to solve this question, but I will show you the simplest one. So here, because they're symmetric, the area to the left of negative z sub 0.025 is also the same as 0.025, equal to the right tail. Okay, so if you focus on the tail to the left, 0.025, and you go inside the table to find the area equal to 0.025, with a bit of searching, you can see that it lays right here. You match it out to the right, you see that is the z corresponding z value is negative 1.9. You match it up, you see 0.06. You add these two values, what do you get? Negative 1.96. So yes, negative z sub 0.025 is the same as negative 1.96. Since these two values are symmetric, positive z sub 0.025 is positive 1.96. So you can try other ways to do it. is thinking of the whole area to the left of z sub 0.025 is 0.975 and go find the area, therefore go find the z-score is shown in the last example. It takes a little bit more work, but it will give you the same way. There are many ways to solve this problem, not just this way. I just want to show you the easiest way. So you can have answers to both values with the work of finding just the left one by remembering the property of symmetry of the standard normal curve. So I hope that this video helped you with some introduction on how to find the area and the z-score interchangeably using the standard normal area table. So try to have some practice with it and then you will get used to it. Thank you and see you next time.